So I decided I would do my own presentation on deploying something with meta-virtualization using K3S, because we usually get a few questions a week on the IRC channel or whatever with somebody either claiming they can't bring it up or it doesn't work or the dependencies are wrong. So I figured I'd work through it and at least have these slides and presentation out there as a reference. So I just want to, I want to show that is the main goal, to show what meta-virtualization can do around some of the container stacks and runtimes. I'm going to show a sample cluster, and we use the word cluster very loosely since it's 2 machines, but it could be more. I also pulled together an application build and deployment built all out of meta-virtualization in Yocto, and then I'll just do some future work. So, and this may run long because I have never timed it before, and we'll just cut it off and everything will be referenced after that. So I just wanted to state before I begin that, you know, when I say deployment, right, this is not about a particular provisioning or deployment stack. In fact, there is no provisioning and deployment stack involved in anything I did, because you go read online, go look for, hey, how do I deploy a K3S or a Kubernetes cluster? And you find a tutorial and they say, oh, it's just this one simple command. And they're running some, not simple command is running some giant script that does all kinds of things in the background to deploy it. So that's not what I'm trying to do. This is not all hidden inside of a giant wrapper script. So I just wanted to, I want to say that that's not a goal. So it's just bare minimum images to bring them up, to show how I can do the multi-node testing using those images, and then show how the image creation and how we can deploy things with meta-virtualization. And finally, I do one thing in the end just to show that a third party, you know, K3S example application deployment that you can find online, how it will actually, so, you know, the cluster is compliant, it will be able to apply to our image, assuming your architecture matches, for example, you know, within those bounds. And it just didn't jump ahead. Did we hang? Okay, we'll click then. The arrow stopped working. You know what? I think I have more interesting bits than this, but I always put it in. Meta-virtualization's been around for a while. K3S was added in 2020, and I updated on a cadence that's sort of carefully picked due to the coordination with everything from containerd to runc to all of the different parts of the stack, but it is sort of constantly updated. And I see that Go updated in OE core, and actually I just ran into it that we weren't able to update anymore because the Go was too old. So now I have to go find out if it works next week with all those new updates. But all right, so this is, again, a very simple test cluster. I just wanted to talk about what I did to set it up. So my requirements are it has to be simple and it has to be virtualized, because I didn't want to mess around with any bare metal, any little boards, any access and serial and everything, right? And it needs to have full networking available, not slurp, not tap, not whatever. It needs to be able to basically show up on my test network as a, you know, a machine like any of my other build hosts or anything that's around. And that is to make sure that the CNI networking doesn't run into any troubles, for example, when the overlay networking starts to come up. So they need to have sort of fully visible IP addresses, not some QEMU slurped 10.42.x.x address. I wanted something that I can actually launch and use outside of OpenEmbedded or Yocto environment, so it's not using run QEMU to launch the machines. And, you know, it uses the base images created from meta-virtualization with no extra no cloud in it, no Ansible, no Chef, no Helm, no anything doing all kinds of magic things after it boots, and that there's sort of a basic configuration that works out of the box with very little tweaking or configuration. So those are my requirements for this test cluster, if you will. And everything that you're going to see was built from master just a few days ago, because my slides weren't delivered all that much ahead of time. I did most of this, bringing it up last week, so everything's quite recent. So I wanted to cover a little bit of this because I've been using something for several years, and you don't see it that commonly used, but for the networking, it's always a problem for me because I need to have virtual machines and physical machines to look exactly the same. I need all these requirements: direct VM to physical adapter access. I need full VM to VM, VM to host, network-wide adjustable, blah, blah, blah. No bridges or other complex routings, networking, and it has to be relatively fast for it over it. So those are, again, my requirements for setting up the networking. And so what I used to use when I was doing OpenStack stuff and work like that about 5 to 7 years ago was Mac VLAN and Mac VTAP. And that includes actually putting the host machines on that same Mac VLAN. So I just wanted to put this here because you don't see this type of networking all that common. And I found it online years ago and I modified a bit for myself, but this is the basic setup where everything, including the host, is hooked onto these this bridge, Mac VLAN bridge, and so all the machines look the same, whether it's physical or whether it's something running in a virtual machine. And that is what gets us that full connectivity, and they get DHCP addresses from my home DHCP server and all good things like that. So for the machine launch, when I'm setting up this this cluster, I'm using ext4 raw images. It's launched from deploy. I'm not using run QEMU. Nothing comes out of bitbake. It is a script that actually knows how to check out and make sure the Mac VTAP is set up to do the launch. It can do peripherals and shared storage. And it adds things like about 2 gigabytes of memory per machine. Otherwise, your cluster, your Kubernetes of any flavor will not launch. You'll very quickly. And so, yeah, and it needs to launch them fast, no parsing time, no anything like that before I launch. So, all right, and I should say I went through that fast on purpose so we could have maybe time for the more interesting parts. But when I'm getting close, I can't see my clock. So if somebody wants to interrupt me and tell me when I'm when I'm out of time, that'll work as well. So the next thing I had to do is that. So basically, that was the first bit of my setup that I didn't actually have working because I haven't been doing much multi-node testing in the past while. It's mainly been single host and worker thing. So I wanted to spread this out to actually more like a cluster. So once I got that working and I could SSH between nodes, and I knew that the connectivity was right, I needed a Kubernetes K3S host and a K3S node image. And right now, sort of by design in meta-virtualization, there are no full image definitions for these. What they are is they're package groups and recipe rdepends for the dependencies. And that gives us the flexibility to use them in different types of images and make sure they're independent and they're sort of self-reliant on all of the dependencies. And that is sort of useful because you'll see in my future work that being able to vary some of the CRIs and the different runtimes is something we want to make more possible, and baking things into images would have been premature on that front. I'll also point out that we're using just the default configuration of K3S, so containerd, runc, all the standard out of the box runtimes and elements they're not being changed. So there's almost no customization is required for a basic cluster. And I built my demos all on purpose again through extension of core image minimal using the Pocky distro and just a few little tweaks in local.conf that I will show. Same layers for both nodes. Basically, meta-virtualization and its dependencies are added to the BB layers. Local.conf, I turned on systemd, added some extra disk space. There's some virtualization, security, and some other required image features that, of course, are checked in the recipes themselves, so they will error if you try to build them without the right distro and image features. I have SSH enabled on those minimal images for debug, and I always turn on, if anybody knows me, package management and PR serve, and I'm using the upstream BB hash server as a test here just to try to, because I was building everything from scratch. And here they are. So I am adding on the host configuration. It's the package group K3S host and kernel modules. In theory, you can get away with not the kernel modules, but we have had issues with not all packages modules being fully in the R recommends in the past. So just to avoid that, I added it in. OpenSSH, adding some certificates, adding some extra disk space for the container store. And then something that I wrote for this that will show up in meta-virtualization is I, of course, immediately blew up my networking when they all came up as QEMU x86-64 and got the same DHCP address and fought with each other. So I have my own way of generating using the MAC address of the builder right now, some unique host names to make sure that didn't happen out of the box. And yeah, that's it. And then I turned on package management and pointed it at my local server, because things like curl and some of the things that you might want are not to do the testing of the application deploy are not on in core image minimal by default. And this is almost exactly the same. So this is the node configuration. The only difference is the K3S node instead of K3S host. All right, so this is, geez, I might get us to, I might get us to the happy hour faster than I thought. This is, I'm going quite quickly, I realize. But so this is my launch of the controller. So this is in the deploy directory, and I just tell it use macvtap. Here's the kernel. Here's the image, and it boots right away. Hooks up to the macvtap bridge, gets an IP address, and up it comes. And you can see I'm using, I used actually one using 5.15 and one using 5.14 kernel to make sure that there was no dependencies on that front. So, so once it comes up and booting on my systems, you have to wait 2 or 3 minutes for everything to finish initializing, and you get the nodes, and you can see that we now have a control plane master, and it's up and running. Ethernet 0 is got a full address on my network at 10.10.10, and Flannel and CNI have come up and done their thing as the overlay network. And here's the worker, again, launched exactly the same way. And you can see this one is using the Yocto dev kernel in this case of 5.15. It booted. And let's just see, you can actually, it's got a slightly different host name, as you can see, QEMU64CB, which makes it unique. It has an Ethernet ETH0 that came up, but no CNI networking at this point because it has not joined the cluster. And so you can see that on boot, I ran my system control status and it is dead. So out of the box, the worker doesn't, it actually doesn't do it. It doesn't do anything because it has not joined the cluster. So there might be, there's different ways to do this, but this is how we document it, and it's fairly simple. So on your K3S on the host node, on the main node, if you get you need to get the server token. And then on your worker, you just do this assistance script that is baked into the image from the packaging. Start the K3S agent with the token, throw out the server's IP address, and it automatically rewrites the systemd environment file with the token and the details of the server, so they'll be there next time you boot. So it's sort of a permanent change. It turns it on, and now that when we now check the status, it's up and running, and we head back to the master. And I give it I give it a label in Kubernetes, because otherwise it's the output isn't quite as nice looking. But now when we dump the nodes, you can see that we have a control plane master and we have a worker node, and they're both up and running. And it took me, looks like, about 34 minutes to get to get things synchronized, same version of containerd, slightly different kernel version, and different IP address, obviously. All right, so that is the exciting way that I did a simple low-level way to bring up the nodes in my cluster. So now what I want to move on to is application build and deploy. And this is actually something that I've had on the to-do list for quite a while, so it was kind of nice. And that is to be able to build within your Yocto environment some sort of application, package it into a container, and then deploy it to your cluster, not using anything but OpenEmbedded and Yocto components. So this was a good opportunity to do that. So what I did was, I think I haven't pushed it yet, but I will shortly. I created a recipes demo subdirectory. I took a simple Python Flask application that I wrote, and it just answers if you do a get on port 9000 Yocto, you get hello from Yocto, and I get on port 9000 OE, you get hello from OpenEmbedded. It also, that demonstration application, it also includes the deployment YAML for Kubernetes. You can do it as a pod or a service, and it's packaged in something called Hello World deploy. And that's what I use to do the deployment here. And it also inherits the OCI container application image, which sets the entry point of the container to be that Flask application. So it is an application container. It is not a system container in this configuration. And here is all of it. This is it. So I wrote Flask app. You get a couple of YAML files. I made some variables that you could fill in because the do install needs to customize them a little bit to your configuration. It installs, and then it's packaged. So that is the entire recipe. Of course, it's not that interesting an application, but it was supposed to be simple. Here is the OCI container image recipe that I used. Again, this is all of it. It includes container base. It sets the OCI image entry point to user bin Flask app. Sets the container shell to BusyBox, which you don't need, but I was using it to debug the layout of the container as I built it. So having BusyBox in there as the container shell means you could actually drop into the container and have a look around to find out why your Flask application didn't get packaged, which I did a few times. And so then we just install Hello World Flask, not the deployment, just the application. I bitbake the application container, and I use Scopio to copy it to my Docker Hub in this case. And you'll all have to guess my password, but it is publicly available. Actually, if you wanted to go run it, you could. So it copies it up in there. So that is the definition of the application. That's wrapping it in an OCI container, that's building it, and then copying it. And that copy from Scopio is done in the deploy directory. There's this app container, QEMU-x86-64 with the timestamp is a directory that the OCI container BB class leaves around for you to manipulate and use. So it copies it up to Docker Hub, and you're kind of good to go after that. The deploy is this simple. I did a very simple one because actually I'm not a big Kubernetes YAML writer. So this is a very simple pod deploy. It's not a service. It doesn't have all kinds of bells and whistles, but this is the entirety of the YAML deployment file, and those variables get replaced during the packaging. So on the K3S master or the host, I did a DNF install of Hello World Flask deploy. I got the Flask app YAML, got dropped in, etc., and I applied it. And so you can see it created the pod demo, and I label it with Yocto rule. Because if you don't label it, some of the further on Kubernetes commands, kubectl commands will not allow you to expose its addresses. So when I dump all of the ingress, the services, and the pods, you'll see that I now have pod demo. It's running. and that's on the worker. You know, it's up and running, but you'll see in that first one, the service Kubernetes, it has no external IP. So we could test it from inside the cluster, but you couldn't test it from another random machine on my network, which is not the most useful thing to do. So the next thing I do, you know, and if you do that, you can write a deploy file that does all this automatically, but I wanted to run the commands to show what's happening. So in this case, I'm exposing its port, 9000 that was defined in the application. I'm telling it to be a load balancer, giving it the name. And you can see it does a little bit of work on CNI to do the mapping of the addresses to set up the forwarding and the ports and everything. And now we have a Yocto greeter service that actually has an external IP address, and we have some services that came up. And that's it. That's your whole deploy in a few simple slides, right? And of course, I went to yet another machine on my network, which is in fact my Mac Mini that I use as my desktop, and I was able to do a curl get to those addresses, and I got my answers from the Flask application running on the worker node. So at that point, that's victory. You have deployed your application. And then, of course, again, like I said, I wanted to show that you could follow somebody else's guide if you wanted to test the deployment of an application. And so there's one that I found that was commonly used as a test. So Nginx, it's a not exactly just for K3S, but it's it has a YAML file to do the deployment. So I don't recommend blindly applying other people's deployment YAML files before you've looked at them, but in this case I did, and you apply that YAML file to the running node, and you can see it deployed Nginx, it created the service, I exposed the port, it's 8001 in the container, and it's port 80 externally. Again, the same way I did the other one, and I could then go to a browser on my network, and I could go to the IP address port 8001, and Nginx is up and running on the cluster. So at the same time as mine. So there you go. That's an application not built by Yocto, not packaged in anything that we used, and we can pull it in and deploy it to our cluster. So at that point, you're into your own management of the cluster using whatever Kubernetes foo that you like to use. All right. I think I am quite fast, which is good. The future work is I am working to finish up some host and node image definitions, but not make them only for K3S. They need to work for Kubernetes and any number of other different hosts and nodes that we have in meta-virtualization. So it makes it a little bit complicated. As I mentioned, adding the ability to vary the CRI, the networking that you want. If you don't want flannel, if you don't want this and that, then there's capabilities there that we can add some variables to make it something that can be extended with other images as well. And to put in a few more deployment tweaks to make sure that some of the things that I had to do after boot with host name and different things like that are something that you could deploy and or generate some files where we could use some of the other deployment frameworks to configure our cluster nodes after the images have been created. I'd like to finish up some of the application build and deploy templates, a little bit more structured than my demo ones that I did, but they are quite handy to show how we can build and deploy an application container. I'd like to finish up a similar demo for full Kubernetes, not just K3S, because K3S has actually gotten more love than K8S, the full Kubernetes recently, and for obvious reasons because of its embedded edge target and smaller footprint. But I'd like to have a similar demo running so we can make sure that full Kubernetes continues to work out of meta-virtualization, and then plug some of these K3S servers and clusters into CI pipelines to see if we could use them, not just to be tested by a framework, but to be the framework for some of the testing for meta-virtualization, in particular, a little bit of dog fooding, if you will. And that's it.